Let's continue on our idea of shifting basic curves around and how we transform the basic curve. If we multiply the function by some constant number, or another way of thinking about it, I could get the k, instead of multiplying it by the function there, I'm dividing the y by it. Obviously, it's an equivalent expression. If k is greater than 1, the curve is going to become steeper. Because you're multiplying every y value by a number bigger than 1, so obviously it's got to go higher. It's going to be steeper. And if k is in between 0 and 1, then the curve will become shallower. Another way of thinking about it is the curve is stretched vertically. Once again, because the k actually is grouped with the y, I can't group it with the x because remember the x is inside the function. So because the k is grouped with the y, it's the y value that's affected. So that's why it's stretched or compressed, depending on the value of k, vertically. The domain will be unchanged. We're not doing anything to the x values. It's the range that may be altered depending. I mean, obviously, if the range is all real y, it's going to stay all real y. But just depending, it might affect the range. Whereas if it's the x value, so inside the function itself, if it's the x value that's multiplied by a constant, then interestingly enough, it still is going to become a steeper curve when k is greater than 1, and a shallower curve when k is in between 0 and 1. But it's going to have an effect of stretching horizontally now, because it's the x values that you're playing with. Okay. So now it might be the domain that changes. The range will be unaltered. Okay. Another common idea is taking the reciprocal of a function. So 1 over some function. So what happens there? Well, if I've got an x-intercept, if I'm turning that upside down, what am I doing? The y value at an x-intercept is 0. So if I turn that upside down, I'm going to get 1 divided by 0, which is undefined. So I must end up with an asymptote there. And the reverse would also happen. So if the original graph had an asymptote, well, logically, if I turn it upside down, it'll become an x-intercept, because it's the reverse of the other situation. If I have a y value that's bigger than 1, when I turn it upside down, it'll become less than 1. And when it was originally less than 1, turn it upside down, it'll become bigger than 1. All right, let's have a look at some of these ideas. So on the one graph, I'm going to draw 3 graphs, y equals x, half x, and 2x. So starting with the most basic curve, y equals x. Well, y equals a half x. I'm multiplying by a constant. It's going to become shallower because that constant is less than 1, or in between 0 and 1. And I guess that makes sense. I mean, if y equals a half x, we know we're going to get a shallower line because the gradient is a half as opposed to 1. And 2x would become a steeper one because now that constant is bigger than. And it doesn't really matter with this one. I can think of it as either way because I could easily move that 2 over to the y and go y divided by 2 and say, oh, it's the y values that are affected. But in this case, it's also times the x. So either way, thinking about it gives me the same result. But I can do the same with any shape. So I've got a parabola. Whee, there it is. Y equals x squared, x squared. So if I look at a y equals a half x squared, now in this case, the half has to be associated with the y value because the x squared, the half's not inside the x squared. Here we go. We end up with a shallower graph. Y equals a half x squared, just like we did over here. We've got to end up with a shallower line. We end up with a shallower parabola, if you like. Because all those y values are being halved. They're coming lower down. And if I had 2x squared, I would now get a steeper parabola because all those y values are being doubled. So, sketch this one. X squared plus y squared on 4 is equal to 1. So I start off and I say, well, I know it's based on the basic curve. X squared plus y squared is equal to 1. But what have I done to it? It's the y values that I've played around with. So there's going to be some sort of either a vertical stretch or a compression. So the edges of this shape will stay at -1 and 1. The domain is not going to change. It's the range that's going to be affected here. And how is it going to be affected? Well, if I think of group it with the y, at the moment y squared on 4 is not grouped with the y. If I group it with the y, I'd actually have y on 2 all squared. So k is equal to 2 in this case. So k is greater than 1. So I know it's going to become a steeper curve. Well, if you think about stretching or pushing, which one is going to make it a steeper curve? It'll be that the stretching will make that a steeper curve. So we're going to stretch it. Whoop, there it is. And we end up with an ellipse. We end up with an ellipse. And that would be 2 and -2 at those points. Okay, one of the reciprocal graphs. Let's look at that. So it's based on the parabola. I'm going to start with the parabola because I can see the x squared. Now what have I done with the x squared? Well, it's negative x squared, so I know it's upside down. But then it was 2 minus x squared, so I've shifted it up 2. So that's the graph of the parabola y equals 2 minus x squared. I'm now going to turn that upside down. So we said the x-intercepts will become asymptotes. So at minus root 2 and root 2, I'll draw in a couple of asymptotes there. Now, there are no asymptotes on the original one to become x-intercepts, so I can't do that. But I said when y is bigger than 1, it'll become y is less than 1. Now, looking at my scale, 1 is about there. But 2 is a point I know. Turn 2 upside down, it'll become a half. So I know that's definitely 1 point. I've just shaded in a little area there because it's saying, well, above that y equals 1, because I'm assuming that's about 1, halfway, it was above. So the graph now will be below. So it will be inside that green section somewhere. I know. Now over here to the left of that rectangle, I've got y values that are all less than 1. So all of these y values will become greater than 1. Whoop. Oh, wrong ones. Let's draw them in. There we go. Right. So I now know the curve will be up here, down to a half, and up. If I look at the edges, again, same idea. There's -1. -1 when I turn it upside down will be -1, so it stays there. Now here it was below, so when I turn it upside down it's going above, so it'll be in this green section here. Here it's above, so when I turn it upside down it'll go below. What other things do I know? I know curves have to bend towards asymptotes. I know I've got to go through that point a half there. I know I've got to go through where y is equal to 1. I've got to pass through those points. I also know, out here at the extremities, it's never going to be positive. Because I can't turn a negative number upside down and get a positive number. So the x-axis must turn out to be an asymptote as well. Let's draw it in. There we go. That's what it ends up looking like. And remember another thing we talked about. We see a pronumeral on the bottom of the fraction. We are expecting some sort of hyperbolic function. And sure enough, at the edges, there's those hyperbolic type graphs there. So we can get some quite interesting ones when we look at the reciprocal. Let's try this one. X plus 1 on x. Well, the way I can do something like this is look at the two different graphs. Y equals x and y equals 1 on x. And I'm going to add them together. So I can slide a ruler along at any point and go, okay, I'm going to add these two y values together. Where's my new point? But there's some logical points to pick. Okay, so I'm going to add the values together. The key points, well, the x-intercept, in this case, I can't do anything with the x-intercepts because I have one x-intercept here, but it doesn't exist in the other curve. So it's not going to exist in the new curve because I can't substitute 0 into 1 on x. So it's not in the domain of that function. So if I'm going to add it to x, it can't all of a sudden magically now go in the domain. Okay? So if it's not in the domain of 1, it will not be in the domain of whatever we're adding together. But the reason we pick x-intercepts is, had that curve been there, well, I'm just adding 0 to the other curve, so I know I stay at the same point on the other curve. Now, so vertical asymptotes will remain. So I know that green line I'll just dot in there. Points of intersection. Well, the y value is the same. So if I'm adding them together, I know it's doubled. So that's why they're good points to draw in. So I'll double the y-intercepts. And I can basically pick as many points as I want until I get a feel for what the shape's doing. So, there's a whole heap of points. So basically I've said, oh, well, the y value of the line, I'll add that to the hyperbola. And I've just done that for several points. And it starts to make sense because the y equals 1 on x, as we're getting bigger and bigger, this is getting closer and closer to 0. So my new graph, if I'm adding it to y equals x, as x is getting bigger and bigger and bigger, I must be getting closer and closer to the line y equals x. And so we end up with, there we go, a little bit bumpy on that one, but some sort of, well, it's an interesting little shape. And the y equals 1 on x and y equals x have become asymptotes, if you like, of the new graph. Isn't that nice? Yes, is the correct answer. All right, so let's add to our ones from yesterday. Just a handful to have a look at, and there we go.